In the sketch below, EFGH is a square, EM is equal to HM, and angle E1 is 50 degrees. Determine the size of angle N1 and angle H2. Let's start with part A. Determine the size of angle N1. Let's mark N1 in our diagram in blue. N1 sits between HF and EM. Now HF is a diagonal. It runs from H to the opposite corner of the square at F. Let's make it green. But EM, let's make it red, is not a diagonal because it runs from E to a point M which lies on side FG. Diagonals of a square may be perpendicular, but since EM is not a diagonal, we cannot be sure if N1 is 90 degrees. So let's make these lines black again and see what else we can work with. N1 also sits in triangle NMH. So let's make this triangle purple. Now M sits on a straight line on side FG, and we know that the diagonal FH bisects angle H over here. But without a given angle, we don't have much to work with here. So once again, let's make our diagram black again. Now, even though we are working with quadrilaterals, we can still use triangles, parallel lines, and angle relationships to help us find the sizes of different angles. So what else do we know about angle N1? It lies vertically opposite angle N3. So let's make this angle green. We know that angle N1, let's make a note over here, N1 is equal to angle N3 because these are vertically opposite angles. Angle N3 sits in triangle EFN. So let's make this triangle purple. And we know that we can use the interior angles of a triangle to find the size of an unknown angle. So let's see what we know about angle E and angle F. We know that the whole of angle E is 90 degrees. So let's make a note here that angle E is equal to 90 degrees. And as our reason, we say because the interior angles of a square are always 90 degrees. So let's make this angle red. We also know that angle E1 is equal to 50 degrees. We can see this on our diagram, so we use given as our reason. Angle E is made up of E1, 50 degrees, and E2, and we know the whole of angle E is 90 degrees, so we can use this information to find the size of angle E2. So we can say angle E2 is equal to 90 degrees minus the size of angle E1, 50 degrees. 90 minus 50 gives us 40 degrees. This is the size of angle E2. So let's take our red angle out of the diagram and put in 40 degrees. And now we can make some space. Now let's have a look at angle F. The whole of angle F is a 90-degree angle. So let's make a note that angle F is equal to 90 degrees. And again, as our reason, we say because the interior angles of a square are 90 degrees. On our diagram, let's make this right angle red. We also know that HF is a diagonal of the square, and the diagonals bisect interior angles. So this means that 1/2 of angle F, F1, will be equal to the other half, F2. If the whole of angle F is 90 degrees, then half is 45 degrees, which means angle F1 is equal to angle F2, and both of them are equal to 45 degrees. As our reason, we say the diagonals of a square bisect interior angles. Let's take our red right angle out, and we can put 45 degrees into the diagram for angle F1, and now we can make some space. Now we have the size of angle E2 and the size of angle F1, and we can use the interior angles of a triangle to find the size of angle N3. So now we can say in triangle EFN, we know the size of angle E2 plus angle F1 plus angle N3 will give us a total of 180 degrees, because these are the interior angles of a triangle. We know that E2 is 40 degrees, so we can say 40 degrees, plus we know F1 is 45 degrees, so we say 45, plus the angle we're trying to find, N3, is equal to 180 degrees. And now we can solve for angle N3. 40 plus 45 gives us 85. So we have 85 plus N3 is equal to 180. And now to solve, we simply move 85 to the right. So we get angle N3 is equal to 180 minus 85, which leaves us with 95 degrees. But please remember that we aren't looking for the size of angle N3. We are looking for the size of angle N1. At the beginning of this question, we found that angle N1 is equal to angle N3. So as our final answer, we can say angle N1 is equal to 95 degrees. Now we can make our diagram black again. We can put in 95 degrees for angle N3 and for angle N1. Determine the size of angle H2. Angle H2 sits at the bottom of the square as part of angle H, so let's make it green. Now let's see what information we have. The small line over here and over here shows us that EM is the same length as HM. So let's make a note that EM is equal to, let's write it as MH. And we know this because this information has been given to us. This tells us that triangle EMH is an isosceles triangle. So let's make it blue. An isosceles triangle has two equal sides and two equal angles. EM is equal to HM. So we can see that angle E, let's make it purple, is equal to angle H1 and H2. Angle E is 50 degrees. So this means that angle H1 plus H2 will also be equal to 50 degrees. And as our reason, we know that this is because these are angles that lie opposite the equal sides of the triangle. Now we have a value of angle H1 and H2, but to find the value of H2 by itself, we need more information. So what else do we know? We know that the whole of angle H over here is an interior angle of a square, and we know that the whole of angle H is equal to 90 degrees because the interior angles of a square are always 90 degrees. Begin here. To make our diagram less confusing, let's take out our blue triangle, the purple angles, and we can make the whole of angle H red. We also know that FH is a diagonal of the square, so let's make it purple. Now we can see that angle H1 over here is half of the whole angle of H. So if H is 90 degrees, then angle H1 must be equal to 45 degrees, half of 90. And as our reason, we say because the diagonals of a square bisect interior angles. And now we have enough information to find the size of angle H2. We know that H1 plus H2 is equal to 50 degrees, and we also know that H1 is equal to 45 degrees. So now we can say the size of angle H1, 45 degrees, plus H2 is equal to 50 degrees, which means that H2 must be equal to 5 degrees. And we have now completed this question.